Episode 18, titled Authentication Protocols, 802.1x, Radius, TACACS Plus, LDAP in Scenarios. We treat authentication protocols as decisions about who, what, and where, because scenario questions are rarely asking you to recite acronyms in isolation. The exam wants you to recognize which layer of access is being controlled, which system is making the decision, and what evidence and logging must be produced afterward. When you think in who, what, and where, you naturally separate network edge access from device administration and from directory lookups, and that separation is the key to choosing the best answer quickly. You also avoid a common trap, which is assuming that every identity problem is solved by the same protocol, when in reality, each protocol occupies a different role in the access chain. Hybrid environments make this even more important because users, devices, and administrators cross boundaries daily, and the control points shift depending on context. The goal here is to make each protocol feel like a distinct tool with a clear home in the access story. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. IEE 802.1x, commonly spoken as 802.1x, is best understood as controlling network access at the edge port where a device or user tries to join a wired or wireless network. It acts as a gate at the point of attachment, meaning the port or wireless association remains restricted until the connecting entity proves it is authorized. In practical terms, 802.1x does not usually make the final authorization decision alone, but it defines the framework for asking the question and enforcing the result at the edge. This is why it is often associated with switch ports and enterprise wireless, because those are classic edge control points where you want to prevent unknown devices from becoming full members of the network. 802.1x environments also support the idea of different postures, such as granting full access, limited access, or quarantine-style access depending on the outcome. In exam scenarios, when you see language like control access at the port, authenticate devices before network access, or enterprise Wi-Fi access control, 802.1x is often the framework being referenced. Remote Authentication Dial-In User Service, commonly shortened to Radius, supports network access with centralized policy and accounting, making it a natural companion to 802.1x in many designs. Radius is frequently used as the back end that receives authentication requests from network devices and returns allow or deny decisions along with attributes that define the access granted. Centralized policy matters because it lets an organization manage access rules in one place rather than configuring every switch and access point independently. Accounting matters because Radius can record sessions and outcomes, supporting auditing and troubleshooting when access issues occur. In a typical deployment, the edge device acts as the authenticator and sends requests to the Radius server, which consults identity sources and policy rules before responding. On the exam, Radius appears when scenarios emphasize enterprise access control, centralized authentication, session logging, or scalable management across many network devices. The key is that Radius is a network access control workhorse, not a device administration control protocol. Terminal Access Controller Access Control System Plus, commonly shortened to TACACS Plus, focuses on device administration with granular command control, which differentiates it sharply from Radius in scenario logic. TACACS Plus is designed for administrators managing network devices, and it supports separation of authentication, authorization, and accounting at a level that can include per-command authorization. This means an administrator might be allowed to log in, but restricted in what commands they can execute, which is a powerful control when you want least privilege on infrastructure management. TACACS Plus also tends to encrypt the full payload of its exchanges, which can be relevant in untrusted segments. But the bigger distinction for exam purposes is its administrative focus and its granular authorization model. When a scenario describes controlling what commands admins can run, centralizing device admin access, or auditing configuration changes, TACACS Plus is often the intended best answer. Radius can be used for device login in some contexts, but TACACS Plus is the protocol most associated with detailed administrative control in network operations. The exam tends to reward choosing TACACS Plus for network device administration because it aligns with the control goals described. Lightweight Directory Access Protocol, commonly shortened to LDAP, is a directory lookup protocol used by many identity systems, and it often appears in scenarios as the directory backbone rather than as the edge gate. LDAP provides a way to query and modify directory information, such as users, groups, and attributes, and those directory results are then used by other systems to make authentication and authorization decisions. LDAP is not typically the on-the-wire protocol that a switch uses to authenticate a port, but it is often how a Radius server, a TACACS Plus server, or an application identity service consults the directory to verify credentials or group membership. In many organizations, LDAP is the interface to a central directory service that defines who users are and what groups they belong to, which means it is foundational to identity policy. In exam scenarios, LDAP shows up when the scenario emphasizes directory lookups, group-based access decisions, or integration between network authentication systems and a corporate directory. The key is to treat LDAP as the directory query layer, not as the network edge enforcement layer, even though it influences those outcomes indirectly. When you keep that role clear, you avoid confusing directory protocols with access control protocols. A useful exam habit is to map each protocol to its use case as access, admin, or directory, because scenario questions often describe the outcome without naming the protocol. 802.1x is about edge access control, which is the act of granting or denying network attachment at a port or wireless association point. Radius is about network authentication, authorization, and accounting in support of access control at scale, often serving as the policy brain for many edge devices. TACACS Plus is about administrative authentication, authorization, and accounting for managing infrastructure devices, with emphasis on granular control and auditable change. LDAP is about directory queries and attribute lookup, enabling other systems to verify identities and apply group-based authorization. When you can do this mapping instantly, you can interpret scenario language quickly and eliminate answers that belong to the wrong layer. This is especially helpful when the exam presents two plausible options, because the best answer is often the one whose core purpose aligns with the scenario's control point. Extensible Authentication Protocol, commonly shortened to EAP, is best understood as a negotiation framework inside 802.1x environments because it defines how the authentication conversation is carried rather than being a single method by itself. In practice, EAP allows different authentication methods to be used within the same edge control framework, which is why 802.1x deployments can support different credential types and trust models. The negotiation aspect matters because the client and the network can agree on an EAP method that both support, and that method choice influences security strength and operational complexity. Some EAP methods rely on certificates, others rely on passwords, and some support stronger mutual authentication, but the key exam-level point is that EAP is the container for the method inside the 802.1x access process. When a scenario mentions EAP method selection, supplicant behavior, or negotiation during network authentication, it is pointing you toward the 802.1x ecosystem rather than toward TACACS Plus or LDAP directly. Understanding EAP as an internal negotiation helps you avoid treating it as a separate access control system. It also reinforces the idea that 802.1x is a framework that can be implemented with different strengths depending on chosen methods. Consider a scenario where an organization needs enterprise wireless access that authenticates employees and applies consistent policy across many access points, because this is a classic case where radius fits naturally. The access points act as edge enforcement, using 802.1x to control association and to trigger authentication, and they forward authentication requests to a centralized radius server. The radius server applies policy, potentially consulting the directory through LDAP to evaluate group membership or user attributes, and then returns a decision along with attributes that define the access granted. This design scales because you can change policy centrally rather than touching every access point, and it supports accounting so you can see who connected, when, and with what outcome. In exam terms, the best answer for enterprise Wi-Fi authentication is often a combination that includes 802.1x with radius as the backend, because that matches the scenario's need for controlled access and centralized policy. If the scenario emphasizes auditing of access sessions, radius accounting reinforces the fit. The important point is that radius is the network access authentication backbone in this case, while LDAP is supporting identity lookups behind the scenes. Now, consider a scenario where the requirement is to manage switches and routers with centralized administrative control and detailed auditing, because this is where TACACS Plus is usually the best match. Network device administration is different from user access to a network because administrators are making configuration changes that can affect the entire environment. TACACS Plus supports administrative authentication and authorization, and it can provide granular control over what commands are allowed, which is a strong fit for least privilege administration. It also supports robust accounting for administrative actions, which is critical when you need to reconstruct who changed what during an incident or a maintenance window. In a well-designed operations environment, devices send administrative authentication and authorization requests to a TACACS Plus server, which applies policy based on role and group membership, often using directory information indirectly. In exam scenarios, when you see emphasis on command authorization, device administration, or audit of configuration changes, TACACS Plus should rise to the top quickly. Choosing radius in that scenario is often a trap unless the prompt specifically frames the need as network access rather than administrative control. Shared secret mismatches are a classic pitfall, because both radius and TACACS Plus commonly rely on shared secrets between clients and servers, and mismatches produce failures that can look like general authentication outages. If the secret configured on the network device does not match the secret configured on the server, authentication requests may be rejected or may fail to be processed correctly, leading to consistent denies that are not caused by user credentials. These issues can be especially confusing when only some devices fail, because the mismatch might exist on a subset of access points or switches, producing location-dependent failures that look like wireless coverage or switching issues. Shared secrets also need careful handling because they are sensitive, and poor secret management practices can create both operational failures and security exposure. On the exam, when a scenario mentions that authentication fails only on certain devices or after a device replacement, shared secret mismatch is a plausible hidden cause. The best reasoning is that the credential might be correct, but the trust relationship between the authenticator and the authentication server is broken. Directory outages are another pitfall because they can cascade into network access failures when Radius or TACACS Plus depends on LDAP lookups for credential verification or group membership. If the directory is unreachable, slow, or inconsistent, the authentication server may be unable to verify users or apply policy, leading to widespread denies or delays that look like network instability. This cascade effect is one reason architects treat directories as critical infrastructure and design for redundancy and local survivability where possible. When the directory fails, it can affect not only network access, but also application access, administrative access, and monitoring systems that rely on identity, creating a broad incident surface. In exam scenarios, if network authentication fails broadly and the prompt hints at directory maintenance, directory latency, or recent directory changes, the dependency chain through LDAP is likely involved. The best answer often includes recognizing and protecting that dependency rather than focusing only on the edge device configuration. Understanding the cascade risk helps you pick designs that fail safely rather than collapsing all access when one directory path is broken. A concise memory anchor is edge access, network AAA, admin AAA, directory, because it maps directly to 802.1x, Radius, TACACS Plus, and LDAP respectively. Edge access reminds you that 802.1x is about controlling network attachment at the port or wireless edge. Network AAA reminds you that Radius is the classic centralized authentication, authorization, and accounting system for network access, especially when you need scalable policy and accounting. Admin AAA reminds you that TACACS Plus is primarily for device administration with granular authorization and detailed accounting. Directory reminds you that LDAP provides the directory query layer used by many identity systems to determine who a user is and what groups or attributes apply. This anchor is useful because it keeps you from mixing the roles, which is the most common mistake in scenario questions. When you can state the anchor, you can usually choose the correct protocol family even when the question never names the acronyms explicitly. To end the core with a selection prompt, imagine a requirement that says the organization needs to authenticate employees onto wired ports, centrally enforce access policy, and also ensure that network device administrators have per-command authorization and auditable change records. The edge port requirement points toward 802.1x for access control at the attachment point, with Radius providing centralized policy and accounting for that network access decision. The administrator command control requirement points toward TACACS Plus because it supports granular authorization for device management and detailed auditing of administrative actions. LDAP appears as the directory lookup layer that both the network access and administrative systems may consult for identity and group information, but it is not the edge enforcement protocol itself. The best exam answer in such a composite requirement scenario often includes the correct division of labor rather than choosing one protocol to do everything. If you can map each requirement to the appropriate protocol role, your answer becomes a straightforward matching exercise rather than a debate. That matching is exactly what scenario questions are designed to test. In the conclusion of Episode 18, titled Authentication Protocols 802.1x, Radius, TACACS Plus, LDAP in scenarios, the main skill is mapping protocol choice to control point and purpose. IEE 802.1x controls edge network access at the port or wireless association. Remote Authentication Dial-in User Service centralizes network authentication, authorization, and accounting for scalable access control, and Terminal Access Controller Access Control System Plus focuses on device administration with granular command control and auditing. Lightweight Directory Access Protocol provides directory lookups that many identity systems rely on, making it a foundational dependency that must be resilient to avoid cascaded access failures. You account for extensible authentication protocol methods as negotiation inside 802.1x environments, and you watch for pitfalls such as shared secret mismatches and directory outages that can masquerade as broader network problems. Recite the Anchor Edge Access, Network AAA, Admin AAA, Directory when you read a scenario, because it will point you to the right protocol family quickly. Assign yourself one protocol selection drill by taking a single requirement you encounter today and stating which protocol controls the edge, which protocol provides centralized authentication, and which protocol supplies directory attributes, because that is the pattern the exam expects you to recognize and apply. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.